In this video, we're going to discuss about different kinds of points in a set. So let's start with interior point. So let S be a subset of R, then X element of S is an interior point of S if there exists a positive epsilon such that the epsilon neighborhood of X must be a subset of S. Okay, so take note, kailangan lang natin mag-provide ng positive epsilon such that dapat yung epsilon neighborhood ng given point ay subset ng S para masabi natin na yung given point na yon ay S. Okay? So another definition, the set of all interior points of S is called interior of S. Okay, magkaiba yung interior point of S sa interior of S. Pag sinabing interior of S, set ang pinag-uusapan natin diyon, and is denoted by int S. Okay, so yung interior of S is defined by the set containing X such that X is an interior point of S. So ito na yung set na naglalaman ng lahat ng interior points of S. Okay, so let's proceed to our example. So tandaan natin to ha, magpo-provide lang tayo ng positive epsilon such that yung epsilon neighborhood niya dapat subset of S para masabi natin na interior point siya. Okay, so example tayo. Okay, so let's have our example. Let's have number 1. So interior of the set of natural number is empty. Okay, so ano ibig sabihin yan? Ibig sabihin, yung set of natural numbers natin ay walang interior point. Lahat ng points ay hindi interior point. Okay? So, paano natin nasabi? Okay? So, let's say, una, kung matatandaan nyo yung definition natin kanina, dapat yung interior point ay element ng given set. So, ibig sabihin, wala sa element ng set of natural numbers ang interior point. Okay? So, paano natin nasabi yon? So, since for any x element of set of natural numbers and for any positive epsilon, okay, kapag kinuha mo yung epsilon neighborhood ng x which is equal to x minus epsilon comma x plus epsilon, so hindi siya magiging subset ng set of natural numbers. Okay, so kung i-imagine niyo, so let's say ito yung number line 1, 2, 3, 4. So let's say ang x natin ay 1. Okay? So hindi tayo makakapag-provide gano'n man kalaki yung i-provide mong epsilon. Halimbawa, i-provide mo ganitong epsilon, liitan lang natin. Let's say ito. Okay? O kahit lakihan mo yan ha. Kahit lakihan mo yan. Meron kasi tayong makikita dito which is not a natural number. Okay? So dito sa epsilon neighborhood niya. Kahit lakihan mo, let's say ilagpas mo dito sa 2. O yes, makakukuha natin yung 1 tsaka 2, but may makikita pa rin tayo sa pagitan nila which is not a natural number. So imposible tayo makapag-provide ng epsilon neighborhood which is a subset of set of natural numbers. So for any positive epsilon and for any natural number x, the epsilon neighborhood of x is not a subset or cannot be a subset of our set of natural numbers. That is why yung interior ng set of natural numbers ay empty set. And for the same reason, yung interior ng set of integers ay empty set. Okay? So next, how about interior naman ng set of real numbers? Okay? So, yung interior of set of real numbers ay yung buong real numbers din. Bakit? Kasi for any real number x, okay, makakapag-provide tayo, let's say, i-provide natin o iset natin yung epsilon to be equal to 1. Kasi nga, ang kailangan lang naman natin, mag-provide lang tayo ng kahit isang epsilon. So, let's say yung epsilon na yun ay equal sa 1. Then, yung 1 neighborhood ng x which is x minus 1 comma x plus 1 ay subset pa rin ng R. Okay? So this shows that the interior of R is still R. Okay? Kasi real numbers, subset pa rin to ng real numbers eh. Kasi yung epsilon neighborhood ay subset of real numbers. Okay? So for the same reason, we have number 4, interior. So subset lang to ng R. Interior of AB is equal to AB, close and bounded interval. Open interval but bounded na AB. Open and bounded interval AB. Okay? So, ito lang yung mga example ng interior point. So, paano natin masasabi kung hindi siya interior point? Let's have another example. Okay, so let's have another example. So, example number 5. Show that 0 and 1 in the close and bounded interval 0, 1 are not interior points of 0, 1. Okay, so yan. So for our proof, so simulan muna natin dito kay 0. So let x is equal to 0, then for any positive epsilon, okay, yung epsilon neighborhood ng 0, which is yung 0 minus epsilon, 0 plus epsilon, cannot be a subset of 0, 1. So, bakit kaya? Okay? So, for example, para ma-imagine nyo, let's say, ito yung ating 0, 1. 0, 1. Tapos, ang point na pinag-uusapan natin ay 0. Okay? So, gaano man kaliit itong epsilon na gagawin natin. So, kapag kinuha mo yung epsilon neighborhood niya, makikita nyo to. Okay? So, eto, mga nasa labas ng ating close and bounded interval 0, 1. Okay? Kahit gano'n man liitan yung epsilon na yan, may makikita tayo dito na nasa labas ng ating set. Which is, ibig sabihin, kung nasa labas siya, hindi siya laman neto. Okay? So, ibig sabihin, ang mabubuo nating epsilon neighborhood, imposible na maging subset nito. Okay? So, since yung 0 minus epsilon up to 0, not including 0, intersection 0, 1 is empty. Okay? So, yan lang yung gusto ko sabihin. Ibig sabihin yan, walang laman ito na nasa loob nito, yung nasa labas. Okay? Sa left side ng 0. Okay? So, for same reason, by the way, kaya for any epsilon, ang ginamit ko kasi nga, para sa interior point, kailangan lang natin mag-provide ng epsilon. Now, yung sinabi kong for any positive epsilon, ibig sabihin nun, hindi ka na makakapag-provide ng epsilon such that yung epsilon neighborhood niya ay subset. Kasi lahat ng positive epsilon, lahat ng positive epsilon, ang mapoprovide mo na epsilon neighborhood ay not subset ng ating close and bounded interval 0, 1. Okay? So, for same reason, if we let x equals 1, then for any positive epsilon, yung 1 minus epsilon or epsilon neighborhood ay hindi rin subset ng 0, 1. So, imagine nyo din dito. So, let's say we have close and bounded interval 0, 1. Tapos, ito yung pinag-uusapan natin. Yung nasa right side naman niya. Okay, yung hindi element ng ating close and bounded. So, since yung 1, 1 plus epsilon, intersection 0, 1 is empty. Okay? So, therefore, 0 and 1, which is element nitong close and bounded interval 0, 1, are not interior points of 0, 1. Okay? So, ganun lang siya kasimple. So, punta na tayo sa another kind of point. So, let's have the definition of exterior point. Let S be a subset of R, then X element of R or a real number x is an exterior point of S if there exists a positive epsilon such that the epsilon neighborhood of x intersection S is equal to empty set. Okay, so padadaliin natin. So dito, mapapansin nyo, para masabi nating exterior point, dapat yung epsilon neighborhood intersection S is empty. Okay? Anong ibig sabihin nun? Ibig sabihin, imposible na ang ating exterior point ay nasa loob ng S. So sigurado tayo na ang exterior point ay nasa labas ng S. Okay? Kasi nga, kung nasa loob siya ng S, ibig sabihin, hindi yan magiging empty. Okay? Pag in-intersect mo dito sa S, yung epsilon neighborhood niya. Pero since naging empty, so nasa labas yan ng S. So kaya nga dito, we have X element of R. Okay? Now, the set of all exterior point of S is called exterior of S and is denoted by exterior of S. Okay, or XS. So exterior of S is defined by X such that X is an exterior point of S. So proceed na kagad tayo sa example. Okay, so for our example, let's have exterior of set of natural numbers. Usually, ang exterior ng isang set ay yung complement niya ng set na yon. Okay? So, kapag kinuha mo yung complement ng ating set of natural numbers, so let's say we have NC, or complement of N, we have negative infinity, 1, union, 1, 2, union, 2, 3, union, and so on. Or, we just have the set of real numbers minus N. So, ito yung mismo yung exterior ng ating set of natural numbers. Okay? So, ito yung exterior ng N. So, kapag kinuha naman natin yung exterior ng Z, so, yung mga complement lang ng Z, so we have R minus Z. Okay? Bakit kinukuha natin yung mga complement? Kasi nga, dapat yung mabubuo nating epsilon neighborhood sa point na yon, tapos kapag in-intersect natin sa given set, dapat empty. Okay? Since wala namang gap sa real numbers, so ibig sabihin, ang mapo-form nating exterior epsilon neighborhood, tapos kapag in-intersect natin sa Z, let's say dito sa given example, empty lang din yung lalabas. Okay? Now, let's have exterior of R. So, for exterior of R, since lahat ng points ng R ay interior points, so imposibleng makakita na tayo ng exterior point dyan. So, we have empty set. Okay? So, ibig sabihin, another information, kapag interior point na siya, imposible na siyang maging exterior point. Okay? Now, kapag kinuha naman natin yung exterior ng A, B, so that is negative infinity, A, union B, infinity. Sir, teka lang. Akala ko ba sabi mo kanina, kapag exterior point, kapag exterior ng isang set, yung complement lang niya. Eh, di ba ang complement neto ay dapat naka-close to? So, bakit open yan? Okay? So, kapag close kasi natin yan at sinama natin yung A sa exterior point, so if X equals A, magkakamali kasi tayo dun eh. Then, for any positive epsilon, so imagine niyo kapag nag-form tayo ng epsilon neighborhood dyan, intersection AB. Okay? So, hindi na siya magiging empty. Okay? Kapag sinama natin yung A. Bakit? So, imagine niyo dito sa ating line, let's have negative infinity, tapos ito yung ating A, tapos we have A, tapos so we have A, tapos B. Okay? So, bubuo tayo ng epsilon neighborhood dito. Halimbawa, clinose natin to. Pag bumuo tayo, kahit anong epsilon pa ilalagay mo dyan, so let's say ito. So may makukuha tayong laman na nasa loob ng AB, which is kapag in-intersect na natin yung AB, ito, tsaka yung epsilon neighborhood, ito yon, hindi na siya empty kasi ito yung magiging laman ng intersection nila. Okay? So hindi na empty, hindi na masasatisfy yung definition ng exterior point kung babalikan natin na dapat yung epsilon neighborhood of X intersection given set S must be empty para masabi natin na exterior point siya. Okay, so ingat-ingat tayo doon sa pag ano ng exterior point. So ibig sabihin dito hindi natin pwedeng isama yung A tsaka yung B, same relation with B as exterior point. Okay? Next, let's have number 5. So kapag kinuha naman natin yung exterior point ng closed and bounded interval AB, so same lang din yan, that is negative infinity A union B positive infinity. Okay? So walang gap ang ating set of real numbers. Ganyang kalakas ng set of real numbers eh. Hindi natin sinama yung A, so infinite yung dulo niyan bago mapunta sa A. Okay? So, ganun lang kadali yung ating, yung concept ng ating exterior point. So, punta tayo sa isa pa. Okay, so let's have another point. Let S be subset of R, then X element of R is a frontier point of S. Okay? If it is neither interior point nor exterior point of S. So, meron tayong tatlong pupuntahan sa isang point. So, pwedeng interior siya, pwedeng exterior siya, at pwedeng frontier siya kung wala siya doon sa dalawa. Okay? So, frontier of S is the set containing X such that X is a frontier point of S. Okay? So, punta na kagad tayo sa example. Okay, so punta tayo sa mga example ng frontier point. So hanapin natin yung frontier ng set of natural numbers. So yung frontier niya, kanina hinanap natin yung interior points niya, so wala siyang interior points. Tapos tinignan natin yung exterior points niya. So makikita natin na yung exterior of N ay yung complement niya. So ano naman yung mga laman ng set N? Okay, kung hindi interior yung laman niya, at hindi rin exterior, so ibig sabihin yung set N siya mismo yung frontier ng N. Okay? Then same reason sa ating set of integers. Yung frontier ng set of integers ay yung set of integers mismo. Then how about yung frontier ng set of real numbers? So since lahat ng elements ng set of real numbers ay interior, so imposible na maging frontier yung lahat ng elements ng R. So ibig sabihin, frontier niya same sa exterior, empty set. Okay, so next, how about yung frontier ng 0, 1? So kung ang 0 at 1 ay hindi interior points, tapos kinuha natin yung exterior ng 0, 1 at hindi rin natin sinama doon yung 0 and 1. So, ibig sabihin, frontier yung 0, set containing 0, 1. Kasi hindi yan interior, hindi rin exterior. Okay? So, same reason para naman dito sa closed and bounded 0, 1. That is the set containing 0 and 1. Pero, may pagkakaiba dito sa open interval 0, 1 tsaka sa close and bounded interval 0, 1 dito sa dalawang to. Ano yung pagkakaiba nila? So punta tayo doon sa boundary point. Okay, so for boundary point, the frontier point which are in set S are called boundary points. So ito yung special case ng frontier point. Okay? Parang dapat frontier points kasi which are. Okay, so boundary of S is equal to yung intersection ng frontier ng S tsaka ng S mismo. So dapat nasa loob. Ito yung mga frontier points na dapat ay nasa loob. Okay? So punta tayo sa example. Okay, so for example, hanapin natin yung boundary ng set of natural numbers. So that is the intersection of frontier ng set of natural numbers tsaka nung given set. And ano yung intersection nila? Kung ang frontier ng n ay n mismo, tapos intersection ng n, syempre magiging intersection niya, that is n. So ibig sabihin, lahat ng elements ng set of natural numbers ay boundary point. Okay? Next, boundary naman ng set of integers. So for same reason, frontier ng set of integers, intersection set of integers ay yung mismong set. Next, doon naman tayo sa boundary ng set of real numbers. So that is frontier ng set of real numbers, intersection set of real numbers, and ano yung frontier niya? That is empty set intersection R, and that is empty set. Okay? Next, boundary ng 0, 1, open interval is equal to frontier ng 0, 1, intersection 0, 1, and that is the set containing 0, 1, intersection 0, 1, and kung matatandaan nyo sa interval, hindi kasama yung 0 and 1 dito, kaya kapag pinag-intersect mo yan, that is empty. Then, kunin naman natin yung boundary ng closed and bounded interval 0, 1, that is frontier ng closed and bounded interval 0, 1, intersection 0, 1, and that is the set containing 0, 1, intersection closed and bounded interval 0, 1, and that is the set containing 0, 1. Kasi dito naman, kasama yung 0 and 1 sa set na to. O yan yung naging pagkakaiba nila. Okay? So yung set containing 0, 1, frontier siya, pero hindi siya boundary ng set na to. So dito naman, yung set containing 0, 1 ay frontier siya, and at the same time siya yung boundary nito. Okay? So yun yung naging pagkakaiba nila.